All right, last reaction. So reaction number 11. So we call oxidative cleavage. Cleavage means cleave or cut the bond with oxygen, with the oxidation. Okay? When I say oxidation, it usually means adding oxygen onto the molecules. Right? If you look at right here, we're going to alkene, add ozone, and then whatever down here, zinc in water, or dimethyl sulfide, this guy right here, either or. All right. So we actually add two oxygen onto the alkene. So we cut the bond of alkene and add 2 oxygen on it. Right? There are 2 ways to do it. One of them use ozone and followed by zinc in water or DMS. The other ways, this is why I'm going to go a little bit further. So we use permanganate, but in elevated temperature. Just put them together in there. Right? In this case, if you see an aldehyde, look like right here. So if you cut this bond right here, you get an aldehyde. For potassium permanganate and in under elevated temperature, the aldehyde will be further oxidized to carboxylic acid. Okay, and we'll talk about this aldehyde and oxidized to carboxylic acid later in the alcohol chapter. This one just introduction to you. Anyway, so I'm going to show you a little bit. So right now you don't really see anything yet. All right. This is a mechanism, and you don't need to know it. Right, but it's just for those of you who are curious, how do we get this? Like, how the heck can we get this oxygen on here? This is how. Right. So we have alkene. This is ozone. They interact from a 5-membered ring. Okay, and then which is not stable. We have still oxygen, and oxygen single bond is not stable, like in the peroxide, like hydrogen peroxide, it's not stable. So it will cleave the ring, open up the ring. You get 2 compounds. Now, this is 1 alkene right here. Get oxygen on it. See that? Yeah, one of the oxygen in ozone become the oxygen onto the one of the double bonded carbon. Now, the other one, we're not done yet. This guy will flip. React back to this guy to the other part, the other half. Yeah, form a more stable compound called ozonide, right? Which will further react with water. Open the ring, react with water. Now we get this guy, the real one. That's a product. That's one product. We're not done yet. And later the hydroxide right here will go attack the peroxide right here to form another part of the alkene. See that? So we will end up with the oxygen on the 1 double bonded carbon and another oxygen bonded to the double bonded carbon. All right. And the step 2 right here, zinc in water or DMS, we use that to destroy the peroxide. Take a look. It's a radical reaction. We'll learn it in a couple chapters ahead of us, and we get the zinc hydroxide at the end. Okay, you don't need to know this. You don't have to. This is how we're going to use it. So if you see ozone will cut the bond like that. Just like you cut your finger and you start bleeding, you have to put a band-aid. And the band-aid is actually the oxygen right there. All right, this carbon got 1 hydrogen here. This carbon got 1 hydrogen there. So I'm showing hydrogen atoms. All right, this is aldehyde. This is aldehyde. Yeah? All right, same thing here. What do we get? Add ozone and DMS. DMS do the same thing with the zinc and water. Same thing there. All right. So cut the bond like that. You should get this compound. All right. Notice that this carbon here got 1 hydrogen on it. Hydrogen right there. All right. Now I want to draw a little bit better than this. This is not really a bond, kind of bond line structure, but it's ugly. So I'm gonna spread it out. Before that, I'm going to name the carbon real quick. So just number it. 1, 2, 3, 4, 5, 6, 7. All right. There are 7 carbons here. So I'm going to draw the bond line structure. 1, 2, 3, 4, 5, 6, 7. Look like that. All right. That's 1, 2, 3, 4, 5, 6, 7. Yep. That's linear, not just weird like this. All right. So that's what does ozonolysis do. Ozonolysis is the only reaction that cut carbon-carbon bond that we learned so far. Okay, it's the only reaction that cut carbon-carbon bond. That's really important, right? Because other reaction we just add things onto alkene. This one we cut the bond and oxidize it, add oxygen to it. Now the other ozonolysis, this one we use potassium permanganate and under elevated temperature. It does further oxidation on the aldehyde. Let's take a look. So same compound right here, just like we did earlier. So you get 2 aldehydes right here. So aldehyde and aldehyde will be further oxidized to carboxylic acid because of we heat it up. All right. So if you see aldehyde, turn that into carboxylic acid. If you see concentrated permanganate and warm temperature. This guy right here, cut the bond right there. Right, so you get that. At the bottom, so there's a hydrogen right here. This is an aldehyde, right? This is an aldehyde. So further oxidize to carboxylic acid. Get that. The ketone the same. Ketone doesn't have hydrogen on this carbon, so don't do anything with it. All right, last one down here. Cut the bond right here, right? So you're gonna have an acetone. This guy we call acetone, and formaldehyde. This guy formaldehyde. You got hydrogen here, hydrogen here. This guy can be oxidized twice, and when this guy get oxidized twice by permanganate, it will go to carbon dioxide, right there. So my point is, if you see a terminal alkene, that part right here, this is terminal alkene, that part will turn to be a carbon dioxide. All right. Okay. All right. Let's summarize everything right here. That's all reaction that you have learned.